Welcome to the day 5 video. Today we're going to talk about compound interest. So in history, banks calculated interest at the end of each year on the original amount either borrowed or invested, the principal amount. This type of interest was called simple interest. As time went on, banks realized that there was another way to compute interest and make even more money. They called this type of interest compound interest. To compute compound interest, the banks calculate the interest for the first period, add it to the total, and then calculate the interest on the new total for the next period, and so on. So basically, that principal amount that we talked about with the simple interest, once we talk to the when we go to the computing compound interest, that principal amount is going to change because it's on the new total for the next period, and so on. So since these are calculating a rate or a percent and the amount is going up, so it's growing to earn that interest, the compound interest formula models exponential growth equations with different letters to represent the banking terms. But other than that, it's very similar to just an exponential growth. So the compound interest formula is A of t equals p, and then in parentheses 1 plus r to the t power. That's very similar to y equals ab to the x power, because when we talk about this interest, it's always going to be growth. So when we're talking about growing, it's going to be over 100%. So that's where that 1 plus r comes from. And if we look at the other similarities, the A is the initial starting amount. Well, that's what the P is also. It's the principal amount borrowed or invested. That's your starting number. Same as A. The B, the rate, is 1 plus R, and that's because of the growth. So it's very similar, but we have these banking terms. The A of T representing the amount earned or owed after T years. P is your principal amount borrowed or invested, so that's your starting number. R is your interest rate or percent, and it is always going to be converted to a decimal. And then T is your time in years. So let's look at some examples. So we have Sarah invested $800 in a savings account that paid 4.2% interest compounded annually. How much money to the nearest cent was in the account after 4 years if she left the money untouched? So let's see, we're starting off with the 800. That's the principal amount. That's what we're starting off at. We're trying to find the amount of money that's in the account after 4 years. So I started off by writing those things above the words. Now you could write them off to the side if you want, or above the words, whatever makes the most sense to you. And then I know that the rate is 4.2%. And remember, to put that into our formula, we're going to need to change that percent into a decimal. And we want to find how much money is in the account. That's my A of 4, because I know what the T value is. So now that I have all this written out, I can go ahead and fill the pieces into my compound interest formula. And I saw that in the word for the problem. That's how I knew that I was going to use my compound interest. When I see that formula, I know I can use the A of t equals and then sub in my principal amount, the $800, and then 1 plus the rate. Remember, we have 4.2%, but I can't just take the 4.2 and put it in. I have to change that 4.2% or 4.2% and make it a decimal that can then be put into my formula. So this becomes the 0.042 or 42 thousandths. That's going to go in place of R in my formula that I had originally written, the 1 plus the 0.042, and then raised to the t power. So I usually start off by writing a formula. Now, if you wanted to skip that part, since they only asked us to find A of 4, you could replace those t's with 4s from the start, but I usually like to put a formula first that can be used for any t value and then plug in the one that they were specifically asking me to find. You could also simplify the 1 plus 42 thousandths or 0.042 to 1.042, but you don't have to. Once we have that all written out, now it's just a job for my calculator. So I don't have to do any of this math. I'm just going to go to my calculator and type it in exactly the way I see it with my parentheses and making sure to put the 4 as the exponent. Remember that that's by using the caret, which is under the clear button. So when you put that all in your calculator, hopefully you end up with the answer 943.106771. Now that's not my final answer because I know we're talking about money here, and money needs to be rounded to the nearest penny. So that means that my final answer is that she will have $943.11. Again, that's because I need to round to the nearest penny. When I look at my 0 in the hundredths place, the 6 tells me to round that up. That's where my 943.11 or 11 hundredths came in. So the final answer is that Sarah has $943.11 in her account. So these questions, you should always think about your answer at the end and just make sure that the answer makes sense. If I end up with a really small number and we know that she's investing money into a savings account, that's usually a red flag that maybe I forgot to put the 1 plus or something like that in my formula. And that's something that I would want to check out. Or if I get a really big number, again, usually a red flag that the money doesn't grow that quickly, or the banks would lose money. Okay, the next question says, if Bailey invested money 4 years ago with an annual interest rate of 3.275% compounded annually, and it is valued at $11,260, how much did she initially invest? So that question there tells me that I actually don't know the principal amount. I don't know what she started off with. So when I look at my formula, I don't know the p-value. So I must know all the other pieces. So I do know the time is 4 years. And I know that the output, the amount that's in the account, so my A of 4, or A of T if you wanted, but I know it was 4 years, that's the 11,260. What I don't know is the p-value, how much was initially invested. So if I wrote this out, so again, using the formula up above, I subbed in the A of 4 as 11,260. P is my unknown, and then I need to do 1 plus the rate, but remember, the rate needs to be changed to a decimal so I can put it in the formula. So I know that the R value is 3.275%, but I need to change that to a decimal. So I need to move that decimal place 2 places to the left to become a decimal that can then go into my formula. So in my formula, I'm going to put 0.03275 in place of the R. Now don't forget, I still have that 1 plus because I'm using the formula A of T. If I wasn't using the formula and I was just thinking of y equals AB to the x power, then I would need to realize that it's an investment, it's going to grow, so it's going to be a 1 plus R since it's an exponential growth. So it's up to you which way seems the easiest. And then again, I know what T is, it's 4, so that's what's going to go in for my exponent. So now I can go ahead and simplify parts of this. So the 11,260 is already simplified. Nothing else on that side. I have P, but I can put the 1 plus 0.03275 raised to the 4th power in my calculator, and that will give me what P is being multiplied by. So in my calculator, that becomes the 1.1375770,311. So now to get P by itself, what's with it that needs to go away? That long decimal. So I need to divide that on both sides so I can get P alone. So then I can put that on my calculator, and I end up with this 9898.23079438856. That's my principal amount. Now, obviously we're talking about money here, so we have to round to the nearest penny. So the amount that would have been invested would be $9,898.23. Okay, so I'm going to stop this video here. There's a couple multiple choice on the next page and a problem for you to try on your own, and we'll talk about it more in class. Have a great day.